Welcome to this session in which we will discuss serverless Java. So before we do so, some logistics. My name is Delabassée. You can find me on Twitter at Delabassée. I work at Oracle. Despite my French accent, I'm not French. I'm from Belgium, from the French-speaking side of Belgium, but still have this funky French accent, so that's something you will have to cope with. This was me some time ago in a conference in Sweden, and someone in the audience tweeted that it's not a real conference unless you read Oracle's safe harbor statement at least once. So here it is. Please enjoy. And last but not least, I'm using a MacBook Pro with a butterfly keyboard. Anybody is using that kind of MacBook Pro with the new keyboards? No? Well, anyway, that keyboard has many flaws. It has been fixed for the fourth time. The design of the keyboard has been fixed for the fourth time a few weeks ago by Apple, and it still doesn't work. So if today any of my demo fails, it's not because of me, it's because of the keyboard. So let's discuss serverless Java. Before we talk about Java in the serverless space, I want to spend a few minutes to just set the stage, discuss about what serverless is. And clearly, whenever I say serverless, I really mean function as a services, FaaS. So what is FaaS? Well, first of all, at the heart of any FaaS platform, we have this notion of a function being a small piece of code that will perform one task. So we have this well-bounded piece of code that will get something in input, and basically the input will trigger the function execution, and the function will produce most of the time some output. That would be the result of the function. It's not a function as we have in mathematics in the sense that a function might also have some side effect, like putting a result in a cache, for example. So you developer will spend most of the time in writing function. And we then have this as a services piece, which is the platform, which is the compute element on which your function will run on. So as a developer, you will write function, and you will give the function to someone else, to the FaaS platform provider. And it's up to the FaaS platform provider to make sure that everything runs. That includes provisioning the platform, scaling the platform, maintaining the platform, securing the platform, and so on and so on. So within the FaaS space, within the function as a services space, we can distinguish two roles. We have on one hand function developers who will focus on writing those very well-bounded pieces of code that will perform very well-defined tasks. And on the other hand, we have FaaS platform provider who will basically maintain the platforms. Clearly, if we look at the market, there is a huge interest for serverless and function as a services. Now, there is always this question that pops up. Should I go for a function as a services approach, or should I use containers? At the end of the day, it doesn't really matter, because if you look at all the FaaS platforms, all of them are using containers, either implicitly or explicitly. So you will see that some platforms are using containers, and it's clearly stated that under the hood containers are being used. Some other solutions are using containers, but they don't necessarily expose the fact that under the hood containers are being used. But for you, it doesn't really matter. So let's look now at serverless Java. So what is the role within the serverless space? So I think that we can all agree that Java is a very popular and widely used programming language. That's a fact. Now, if we look at Java within the serverless space, we don't have a lot of metrics, but the few metrics that we have are not that great for Java. So this is a survey that was conducted some time ago by the serverless frameworks. So basically, the serverless frameworks is a solution that gives an abstraction on top of different FaaS platforms. And you can use different language. So the question was, what are you using today to write your serverless function on top of the serverless frameworks? And you see we have this big green arc, which is node 6.10. So basically 70% of the users of the serverless frameworks are using JavaScript to write serverless function. And not only that, if you add that to users that are still using node 5, basically over 75% of users are writing function using JavaScript. Then we have Python. So if you add Python 3.6 to Python 2.7, basically 15% are using Python to write serverless function. And then we have Java, this small yellow box at the top, which is Java 8, and it's not even 5%. So less than 5% of users are using Java to write serverless function. So it's not really great, right? And the next question they asked was, OK, we know that today you are using that language, but what do you plan to use in the future? And well, basically, you see that Java is flat, below or around 5%. So there is no progression when it comes to developing function using Java with the serverless frameworks. So how can we explain that on one hand we have a very popular and widely used programming language, Java, and on the other hand, Java is not really used within that space? Well, first we might want to look at the historical serverless landscape. It's a pretty young landscape. But still, if we look at the three major fast platform solutions in that space, that is Amazon, Google, and Microsoft, well, we see that for Amazon it's okay, because they are supporting Java since 2015. So Amazon is good on the Java support front. For Azure, they are only supporting Java 8 since February this year. So it's a pretty new offering. So that might explain why users are not necessarily using Java within this fast space. For Google Cloud Function, they are only supporting Java 8, and it's in alpha stage, and it's only since April this year. So that's still very immature, right? So clearly that might explain why Java is not very popular in that space. Now, we also think that Java is not very popular today in that space because we basically see trends where basically startups and new services are being developed using any type of technologies, and it's only when those services and the offering needs to mature that those solutions are being migrated to Java. So over time, we might expect to see solutions which are written using Python, JavaScript, doesn't really matter. We might expect to see those solutions to evolve toward Java. So that's something that will only happen over time. Now, there might also be something else to explain why Java is not very popular in that space. Maybe Java is not a good fit, as simple as that. Java might not be very well designed for the serverless space. I mean, we all know that Java has evolved over time to cope with long-running application. And clearly here we are talking about very short-lived application. A function will only live for 100, 200, 500 milliseconds, and then it will die. So functions are by nature ephemeral. They will be invoked and then they will die. So maybe Java is not a good fit for writing such a type of application. So when at Oracle we started to work on our fast solution, we wanted to make sure that Java was a good fit for the serverless space. So we basically set ourselves some kind of goals that we wanted to achieve with Java within the fast space. We want to have the ability to use plain old Java. We want to give the function developers the ability to use the tools they are using today. Functions are by nature designed for a very short-lived, stateless application, but still, there are some use cases where it makes sense to give the ability to the developers to write more complex applications. Then, given that we're talking about very ephemeral application, we also need to make sure that we can deal with the performance and the latency that we expect for functions, those kind of things. And last but not least, we also need to make sure that we can cope with the rich Java virtual machine ecosystem that we are living in. So basically, I will discuss all those points through my presentation, and I will illustrate that with a few demos. So for that, I'm going to use FN, which is an open source fast platform. So FN is using the Apache v2 license. Everything is on GitHub. So one of the benefits of an open source fast platform is that you can take the platform and run it on premises or in any type of cloud. Obviously, if you are taking a fast platform and running it by yourself, that basically means that you will have to deal with the two roles. You will be the fast platform users, so you will be the function developers, but you will also be the fast platform provider. So you will have to somehow manage the platform. But if you understand that, that's perfectly fine. And having the ability to use the fast platform on any platform also gives you the ability to basically use the platform on your laptop, something which is very convenient for development, for example. Technically, FN is written in Go. So FN stands for function, and it's written in Go. It makes sense, given that it's basically an infrastructure project. You will see through my presentation that FN is using under-the-hood containers. So basically, FN is based on Docker. That's something that you can leverage, but if you don't want to leverage, well, if you don't necessarily need to understand how Docker works to use FN. That's something that I will show you. So FN is written in Go, but still, as I told you, we wanted to make sure that Java is a first-class citizen on top of FN. So that's one of the goals that we set ourselves. So github.com/fn project/fn, that's basically the main repo. Everything is there. So let's have a look at FN in action. So FN is using Docker. So I have Docker running on my machine, but let me kill that so that we start. Oops. Docker. Oops. So I'm going to kill all the containers that I have running so that we can start from a fresh setup. Still like this one and this one. So Docker PS, and it's empty. So the first thing that I'm going to do is to start FN. So for that, I'm going to use the FN CLI. So it's this FN command. So the FN CLI is basically your gateway to FN. You can do everything like starting FN, stopping FN, bootstrapping function, testing function. You can do all of that through this CLI command. And now FN is running on my machine. So if I do a Docker PS, I have FN running on my machine. So the next thing that I want to do is bootstrap a function. So I want to basically have a function that I can easily extend. So again, I'm using the FN CLI, so FN init, runtime. Then I need to specify which runtime I want to use. Given the context, I'm going to use Java. But out of the box, FN support Go, Python, you name it. So the next thing that I need to do is to specify the name of the function. So let's give it a very meaningful name like Duke. And if we look at the Duke directory, we have a few files which have been created for us. So there is a pom.xml. So basically, a serverless Java function in FN is simply a Maven project. So that means that you can keep using Maven. So for example, Maven test. That will unit test my function on my laptop. And obviously, the tests are passing. Let's see. So we have two classes which have been created. So this is the test, hello function test, that's the test, and this is the hello world Java function that FN is creating for us. So the next thing that we want to do is to run the function. To run the function, we need to deploy the function to an application. An application is simply a namespace, basically a way of grouping together a related function. So let's create an app that is called Krakow. So if I look now at the applications that I have running, I have a bunch of apps, including Krakow. And if I FN list the function within the Krakow apps, there's no function, right? Makes sense. So the next thing that I want to do, I will deploy my function so that I can run it. So FN deploy, the app that we want to deploy to is Krakow. I don't have to specify the function, given that I have a func.yaml, so maybe I should show you what is the func.yaml. So that's basically a file that contains some metadata about the function, like the runtime to use, the entry point, which is at the bottom. So this is the Java class, and this is the method in our Java class that corresponds to our serverless function. So FN deploy, Krakow, and I'm going to let's see, I'm going to add -v so that we can see what happened behind the scene, and I'm going to add the local flag just to save some time. And basically, you see behind the scenes that the FN CLI is using Docker to basically build a Docker image of our serverless function. So now, if we look at the function within the Krakow apps, we now have the Duke function that we can invoke. So FN invoke Krakow, and the function is called Duke. So again, I'm using the FN CLI, and it's a simple hello world. I'm using the FN CLI to invoke the function. That's just a shortcut. But if I inspect Krakow and Duke, if I inspect the function within the, you see that I have an invocation HTTP endpoint that I can use. I can also add additional triggers, like an additional HTTP triggers to invoke my function through HTTP, right? So it's a Java function. It's a Maven project, so that means that we can use our IDE. So the project is imported. Okay. Okay. So if we look at the source of the function, so main and test, this is main. This is our function. So you see that it's basically a simple method in this case that will get a string and it will produce a string in output. Something that you should also see here is the fact that there's no annotation, there's no specific interface. So basically, this is really plain old Java code. There's nothing specific here to FN. So in this case, we get a string in input, and we produce a string in output. That's pretty basic, so let's do something else. Let's create a new type. So let's create an event type. So an event has a name and a date. Let's see. So I need a constructor. I need a default constructor, and I need getter and setters. So basically what I've created here is a simple event type. It's basically a simple POJO. It's a simple bin for an event. So now what I can do this, event equal new. And we're going to use the input as the name of the event, and today's date as the date, right? And we're going to return that new object, event, and obviously I need to change the signature of the method. So basically here, the function gets a string in input, and it will produce this new event type. So to run the function, we're going to deploy the function again. So the function will be rebuilt. And it doesn't work. Anybody has a guess why? So if we add the -v flag, we'll see what's going on behind the scenes. So you see that the function is being rebuilt. And when the function is built, the function is being tested. And obviously, I need to update my test, given that I have changed the function. So I need to fix my test. What? That's a joke. That's only something that you can do on stage in front of a large audience. Don't do that at home. But you get the idea. So let's redeploy the function again. And you will see. It should work. Yeah. So you see, that's a nice way to fix the test. Again, don't do that at home. So let's invoke the function again. So for that, I'm going to pass some payload to the function. So Devoxx Krakow. Invoke. The app was Krakow, and the function is Duke. So it should work. And this is the result of the function. Let's GQ that. So this is now the output of the function. My function is outputting this new event type, and automatically it's converted by the FN platform to JSON payload. But again, if you look at the Java code, we didn't have to do nothing to do the marshalling and unmarshalling to and from JSON. Well, here I'm only using JSON in output, but obviously if I was using a different type, I could pass that different type to my function. And I would have to pass a JSON document to my function, and automatically it will be transformed to a Java corresponding type. So that's basically in a nutshell a very quick FN demo. So this is something that that FN provides. FN provides multiple function development kit, multiple FDK. Here I've used the Java FDK. So the Java FDK gives me Maven support, give me JUnit test, give me the ability to do input and output coercion, so passing a different type to my function, and automatically the JSON conversion is handled, and different other capability that we'll discuss later on. So using the FDK, we have the ability to basically keep using plain old Java, and we also have the ability to basically keep the tools that we have been using for many years, like our IDE, Maven, and so on. So you can easily integrate that within your existing tool chain, right? Now let's talk about the ability to build complex applications. And that's something that is provided by FNflow. So I told you at the beginning that functions are short-lived. So a function is a very basic task. It will basically be invoked, perform its task, and then it will die. There is a specific use case where it makes sense to have more complex function. So in the first use case, you wouldn't want to handle the state within the function. It's too short-lived to handle the state within the function. That would be too expensive to handle the state within the function itself. So if you need to hold some kind of state, you need to do that outside of the function. Having said that, there is a specific use case where it makes sense to hold the state within a function, and that is when you want to compose together multiple functions. So think the following. You have a function that will invoke another function. We're going through the network, so this is an asynchronous invocation. It might take some time. At some point in time, the main function will get the result of the function invocation, and based on that, the main function will do something else, like invoking another function, or maybe the function invocation fails, so the main function will have to deal with those errors. And that's basically where fnflow come into play. fnflow gives you the ability to do that function orchestration. From an API standpoint, it looks exactly the same as the completion stage API that we have in the Java platform. So the completion stage API is basically an API that is part of Java that gives you the ability to define pipeline execution of asynchronous tasks within the GVM itself. The completion stage is exactly the same idea, except that given that we're talking about pipeline of function invocation, we have to go through the network. So obviously, this doesn't happen within one single process. It basically happens through the fast platform itself. From an API programming standpoint, it doesn't matter, because the only thing that you're using is the API, nothing else. So you don't necessarily need to know that whenever you invoke a function, we are going through the network. This is how the API looks like. So we have this flow object. We have this, so from the flow, we create a stage. So a stage will basically contain the result of a function invocation in the future. It will either contain the result of a function invocation, or it might also contain an error, because something might go wrong. So the second line is basically where I define the pipeline execution of my function invocation. So in this case, it's pretty basic. I just invoke a function, and once I have the results, I'm doing something with the result. And that line is only about defining the pipeline. Nothing happens on that line. It's really only when you do a get that basically you are asking to the underlying fast platform to trigger the pipeline execution of functions. So to illustrate that, I have a demo that basically is using multiple backend functions written in Java, Ruby, JavaScript, Node, and Python to book a trip. So whenever we want to book a trip, we want to book a flight, we want to book an hotel, a car, and once the trip has been booked, we want to send a mail to the user with all the details. And we're going to use this trip booking function that is using the fnflow API to basically do the orchestration of the multiple backend function. So we're going to use Java to basically invoke multiple functions, and it doesn't matter if those functions are written using Java, Ruby, and Python. Given that we're on the Java side, we're going to use the fnflow Java API. So let's have a look at that. So So I'm going to start a few things. So if we look at the container that we have running, so we just have the FN server that is running. So now I'm taking my fast platform provider hat, and I need to do some additional stuff. So I'm starting additional containers. And really, there's only one additional container that is needed, and that's this one, the flow server. So basically, that's an adjacent services that will manage the state of the flow function. Now, I'm also using those two containers, but those are just for my demo so that we can see what happened behind the scenes. Just configuring my function to make sure that everything is OK. So if I look here, I have a travel apps, and if I list the function within that travel apps, I have a bunch of functions. So basically all the backend function, and we have the trip booking function at the bottom. So that's the one that we're going to invoke. So for that, I have some simple payload that I need to pass to my trip booking function. So let's see, fn invoke, so the application is travel and the function is trip. So here I'm using one of the additional containers so that we can see what is happening behind the scenes. So let's invoke that guy, and let's switch here. And basically here we can see what's going on. So this is the main trip booking function. We are invoking the flight booking function, then we're trying to book an hotel, we're booking a car, and finally everything is okay, so we're sending a confirmation to the users. So what we can do, we can invoke it a second time. And we see it's way faster, because the platform is basically container. So the first time you invoke a function, the platform needs to basically start that container for that given function. But obviously, the subsequent time, the platform is keeping those containers hot, so that it can basically reuse those containers, so just to save some time. Obviously, at some point in time, those containers will time out. So this is the happy path. Everything goes well. So let's have a look at the not so happy path. So that's the second services that I'm using. So you see that basically each time I'm invoking my services, everything goes well. Now, I have these tools that basically helps me to break my demo. So anytime I will try to book a car, it will just fail. So let's invoke the same booking again. And here we should have a different behavior. And you see that basically we were able to book a flight, we were able to book an hotel, but we were not able to book a car. So basically, the trip booking function is doing a rollback of all the booking that we did to make sure that we didn't just book a flight, for example. And at the end, we send a mail to the user saying, okay, sorry, but we were not able to book that trip for you. So this is basically, in a nutshell, what Flow and specifically the FNFlow API gives you the ability to do, function orchestration. So it's not a silver bullet. You won't write any type of application using the FNFlow API. But whenever you have that need to write, whenever you have that need of function orchestration, so multiple functions that need to be invoked, the FNFlow API is something that is very useful. All that code is on GitHub, so I really encourage you to check that out. So ability to build complex application, yes. But again, it's not a silver bullet. You will not build any type of complex application. It's only for function orchestration. That's something that is perfectly possible to do using Java, using the FNFlow API. Now let's talk about this whole latency and high performance issue that we might have with Java. One of the issues that we often see with Java is the fact that people think that Java is very slow to start. So over time, we have technologies such as the JIT and so on that will basically improve your application while it's running, but the startup time might be expensive. And obviously, if you have a very short-lived application, the startup time is something that is very important. So that's something that we have to deal with when it comes to Java within the serverless space. So at the end of the day, we have to keep in mind that our Java serverless functions are just containers running Java. So basically, it boils down to Java running within containers. So what we want those containers to do, we want them to start as quickly as possible. Something else that we expect from those containers running Java, we expect them to respect the fact that they're running within containers. So I will not go over that slide because it's very busy, but the takeaway of that slide is basically, if you look at Java since Java 8, we have invested in the platform to make sure that Java can work nicely when it is running within containers. So if you take an early Java 8 version, for example, if you run that GVM within containers, the GVM will not have access, will not understand that it runs within containers. So it will look at the metrics from the host systems. And that's something that is very problematic because in Java, we have this notion of ergonomics. So basically, the platform, the GVM will basically look at some key metrics, the CPU and the available memory, and it will try to auto-tune itself so that it gives out of the box a very decent behavior. Obviously, if you're running Java, a very old GVM, within a containers, the metrics that will be used for the ergonomics will be the host metrics and not the container metrics. And if you are doing that, you can expect to have a very bad issue very quickly. Anyway, this is something that has been solved. So if you take any supported modern GVM out of the box, that GVM supports C groups. So it will access the resources from the container and not from the host. So something else that we expect when we have Java serverless function to run within containers is we want it to start as quickly as possible. So there are multiple techniques that we can use, like CDS, class data sharing. So CDS is not something new. It's something that has been in Java platform since Java SE 5, so 15 years ago. So it's pretty, well, it's a pretty mature thing. So CDS is basically about giving the ability to, well, think the following. When you start a Java application, you have a jar, and that jar is unpacked. The class are being brought into memory, so the bytecode is scanned by the GVM. So many things happen on all the classes of your application before the code can be run from the memory. And this is a very expensive operation. And the thing is that obviously you have a bunch of classes. So this is something that is very expensive, and that's something that needs to happen every time you start that piece of code. CDS is basically about doing that operation, those operations once. Once this is done, we have all the class, well, we have all the in-memory representation of the bytecode that is basically dumped into disk. So the next time that your code is starting, the GVM will basically just take that snapshot and bring it directly into memory. So it doesn't have to go through all the steps like security checks, and so on and so on. So basically, by using CDS, you can save like 25% of the startup time of your Java code running in, well, not even running in container. Outside of containers, obviously, CDS works too. So that's obviously something that we're leveraging on the serverless side. If you're using FN, that's something that we do out of the box, so you don't have to mess with any GVM flags to use CDS. So CDS at the beginning was for the runtime classes, but since Java 10, you can also use CDS for the classes of your applications. Now, application CDS within the serverless space might not be as useful as plain old CDS. So at this stage, we're not using application CDS. Now, when it comes to the startup time of the serverless Java function, and it's not specific to Java, it's basically, it applies to any type of function. We want to make sure that the container starts as quickly as possible. So we have to think about the fact that our container is made of different layers. And if we want to reduce the startup time, we have to make sure that we are sizing those layers appropriately. So basically, we want to make sure that our container layers are as small as possible. That's something that we have to deal with. So if we look at Java serverless function, basically there are three types of layer. The Java function and its dependency, so that's the layers for which we don't have a lot of controls. I mean, the advice that we give you as a function developers, basically watch out of the dependency that you're using. Don't bring any transitive dependency that are not needed, those kind of things. But at that level, there's not much that we can do as a platform. Now, if we look at the two others layer, the Java runtime layer and the operating system layer, there are things that we can do and that we do. At the OS layer, basically, we want to shrink the OS layer as much as we can. So for that, we can use a highly optimized Linux distribution, such as Alpine. Alpine only weighs, well, those days, it weighs a little bit more than 4 megabytes. So basically, you have a Linux distribution that is secure and that carry everything that we need to run your serverless Java function. There's an issue. So Alpine is based on muscles, and OpenJDK is basically using libc. So basically, the C library that the GVM is using to talk to the operating system is for OpenJDK libc, and Alpine is using a different one, muscles. The good news is that there's Project Portola, and the goal of Project Portola is basically compiling OpenJDK with muscles, so that it can run on top of distributions such as Alpine. That's something that we will see later on. So the next layer that we can work on is the Java runtime layers. So to give you some idea of the benefit that we can achieve, we need to start from a whole GDK. GDK 12 weight, let's say 320 megabytes. So first, to run a function, it's a bit stupid to use a full GDK, because clearly when you run a function, you don't need, for example, Java-C. And it's a good practice to have image that doesn't carry anything that is not needed. So you should at least use a GRE, right, to run your function, and not a whole GDK. Having said that, there's no GDK 12 GRE, but to give you some idea, I took OpenJDK 11 GRE so that we can have a sense of the size of a whole GRE. Let's say 220 megabytes. So just by switching from the GDK to the GRE, we already save 100 megabytes. Now, you know that since Java 9, we have the modularity within the Java platform. So we can use JLink to basically construct a GRE that will only carry the modules that our function needs. To give some idea, I did something very stupid. I basically build a custom GRE that includes all the modules. That's something very stupid because that JLink is not meant for that. And not only that, I'm not sure there is a technical way to write a meaningful function that is using all the modules. Nevertheless, that's what I did, 168 megabytes. JLink gives us the ability to remove some information from that custom runtime, like header file, main page, and so on. So if we are doing that, we can save another 25 megabytes. JLink also offers two levels of compression. If we are using compression 2, which is zip deflate, we go down from 143 megabytes to 83 megabytes. So we save another 16 megabytes, which is a lot, right? And obviously, what we want to do is basically use JLink as it was designed to. We want to use JLink to create a custom GRE. If we are doing that, our GRE will only weigh 47 megabytes, which is a huge win. From those 47 megabytes, we can still remove useless information, such as header files and main page. We go down to, let's say, 42 megabytes. And if we compress that, we go down to 32 megabytes. So basically, by using JLink, we can go down from a full GRE that weighs 168 megabytes to 32 megabytes. Now, to be fair, the idea of using JLink is basically to reduce the Java runtime layer size. So we shrink the layer of our Java runtime layers, but we have to keep we have to keep in mind the cost of uncompression. So if I take my 32 megabytes, maybe the 10 megabytes that I will save will not be worth it. The compression might be more expensive than that. So that's something that we need to measure. So let's have a look at how you can do that within FN. So I'm going to bootstrap a function in it, and I'm going to use a different approach. JLink init, and I'm going to call this function, JLink. So this is a simple Java function. I'm going to deploy this function to Krakow. Let's say JLink. And I'm going to use local so that I don't push my function. So fn invoke, my function is deployed. So Krakow. So this is a very stupid function, but we should. So basically, it's a simple Java 12 function. We give it a day, and it will give us some result. It's not really what is interesting here. But if we look at the size of this function, so basically, I'm using div. So those are the different layers of my Java function. So 4.1, that's the operating system. That's Alpine, so super lightweight. 2.4, it's the function layers with its dependency. So we have the function.jar here, 3 kilobytes, and then the rest is just dependency that are needed by the function. And then we have this 33 megabyte, which is the Java runtime, the custom Java runtime that carry all the modules and only the modules that are needed by my serverless Java function. And I also have this 19 kilobyte, which is just a shared object that is needed by the platform. So basically, by using JLink, so Java modularity with Project Portola, the ability to run on top of Muscle and hence Alpine, I can create serverless Java function image that only weighs 40 megabytes, which is obviously super lightweight. And that's something which is important when it comes to startup time. Because you have to keep in mind that each time you start up, the platform start your function, it has to basically bring from, it has to do a Docker pull, basically. It has to go from the to the registry and fetch that image and start up that image. And you saw that to use JLink and Portola, well, as a function developer, you only had to use that flag. Init image, JLink init, and nothing else. You didn't have to deal with containers and so on to do that. We can go further than that. And for that, we can use GraalVM. So GraalVM is, well, there are many sessions on Graal in this conference, but in a nutshell, that's a polyglot, high-performance virtual machine developed by Oracle Labs. It provides many capabilities, but one of the capabilities that is interesting for us is the native image capability. That gives basically the ability to take a Java application, so Java bytecode, and turn that into a native executable for a given platform. So let's have a look at how Graal works in FN. So I'm going to create a Graal function. And I'm going to use a different init image, native init. And I'm going to give it a very meaningful name, native. So if we look at native, basically we have a bunch of files which have been created. And if I deploy that, fn deploy, maybe I will not do it entirely because it's a bit expensive. So fn deploy app native. The function will be built, so first it will be compiled to, oh yeah, it was already cached, actually. So the function is built using Java here, so a Maven package. And then we are using the native image capability of Graal to basically turn that jar, so pure Java bytecode, into a native Linux executable that will run within our containers. And again, if we look at this, so first let's invoke that function. So fn invoke, what was Krakow? Yeah, Krakow. Fn invoke, I said invoke, Krakow, native. It's just, well, it's a very basic hello world function. But if we look at the function itself, so this is the image of the function. So those are the layers of the function. So 4.4, that's the operating system layer. 16 megabytes, it's basically the function layer. So it includes the function itself and all its dependency and also the substrate VM, all of that embedded within one Linux executable that is here. It's this func file which only weighs 16 megabytes. And obviously, we still have this 19 kilobyte shared object that is needed by the FN platform. So this is basically all it takes to leverage Graal on top of FN. And again, the idea is basically to reduce as much as we can the startup time. Not only that, when we are using Graal, we're also improving the footprint, the memory footprint of that application. So low latency, high performance, when it comes to serverless Java, I think that we have many tricks and techniques that we can leverage to basically achieve the performance that we expect from a serverless Java function. And most of the time, those are handled by the platform. So you don't need to understand how Graal works, you don't need to understand how JLink works, and so on. This is something that is handled by the FN platform. Now let's quickly discuss about the rich Java virtual machine ecosystem that we live in. So you know that since sometimes, every 6 months, we have a new Java release. Not only that, we have Java, the programming language, but we also have Kotlin, we have Groovy. So there are a bunch of other languages that run on top of the virtual machine. And then we also have additional projects such as Graal. So basically, we wanted to make sure that with FN, we were able to cope with that rich ecosystem. And that's basically the init image capability. That's what the init image capability provides, the ability to basically cope with that ecosystem. So that's something that you can also use as a developer to add support for language which are not supported by the platform. Someone from the community has, for example, added support. It has contributed support for the .NET language. Not something that we were going to do, but given that everything is open source, it's pretty easy to do. That's something that I've used to add support for Groovy, so you can write a serverless Groovy function. That's also something that I've used to support Kotlin. You can, using the init image capability, write Kotlin serverless function. And that's also something that we're using internally to support Graal and JLink. So let's have a look at a quick demo. So fn init. That's also something that we are using to basically support the new Java release. So I'm never sure of the name. I think it's Java 13 init, and let's call this one Duke 13. Yep. So this is a Java 13 function. Let's have a look at. The thing is that To prove that it's in the Java 13, and you might have to help me. Java property, I think it's Java version. So yeah, something else. When I started to program, I was told that I always need to use meaningful variable names. So now in Java, we can finally do this variable. So if I deploy this function, fn deploy, let's have a look if it works. It doesn't. Maybe I did a typo. Sorry? So I can't hear you. Oh, sorry. Yeah, it's you have a big screen. I have a small screen. Oh no, let's say it's the keyboard. So fn invoke, Krakow, I think, Duke 13, and if everything works well, yeah, it's indeed a 1311 GVM that is running this very stupid Java function. So init image basically gives us the ability to support the Java the GVM ecosystem, and it also gives you the ability to add support for a language which are not supported out of the box by FN. So that's something that we can easily do. So serverless Java, does it have a future? Absolutely. With projects such as OpenJDK and GraalVM, I think that it's just the beginning of Java within the serverless space. And to be fair, today I've used FN because I've been working on that project, but if you take any other serverless platform that support Java, most of the things that I've discussed today also applied to those platforms. So FN is a very good example of Java running within the serverless space. We're doing extra things like FN Flow and so on, but most of the things like the Graal support and those kind of things is something that would also benefit the other platform. So the call to action, give it a try. The only thing that you need to use FN is to have Docker running on your machine, and in less than 2 minutes, you will be up and running with your first function, bootstrap it and deploy on your FN server. And if you like it, please give us a star. That's a very stupid metrics, but that's something that we also highly appreciate. So please give us a star if you think that this is something that might be useful. So I will very quickly mention that Oracle is obviously working on a managed fast platform, Oracle function, that under the hood is using FN. So if you don't want to deal with the fast platform provider hats, well, give Oracle function a look. I mean, it will be launched shortly, and we will have a free tier that you can give it a try without paying anything. So it's something that you might want to consider. And with that, I'd like to thank you for your time. Thank you.